Welcome to my channel, but not to my workshop. As often, I'm travelling for work at the moment. I've just made a new video and it's all about making some beams and some lifting equipment for my Project Harrison milling machine. Now, I lost some of the footage while I was doing this, and in order to sort of get some continuity back, I'm recording this little piece now, and I'm also going to show you the milling machine and some of the details of it in the manual, so that what is left of the footage will make sense when I put it all together. So I hope you'll enjoy it regardless of these amateurish production values, shall we say. Okay, I hope you enjoy. So this is what my Harrison milling machine looks like, and indeed what they pretty much all look like. The difference between this drawing or photograph than mine is that mine's got the vertical head assembly which fits onto here, where the horizontal milling arbor goes. I've also got the overarm and the support, so I can do horizontal milling as well. So I've got the best of both worlds, really. This one shows a clutch lever to engage and disengage the drive, which mine doesn't have. There were numerous different variants of this machine. The one that's shown here is the most like the one I have. Although I don't have this clutch lever, my power feed gearbox is in this position here. And at the moment I have the table and the saddle assembly removed. The power feed gearbox is removed, and the lead screw is removed from the table, and this lead screw is removed. The Traverse lead screw is off as well. And so all I've got at the moment is the main body of the machine, which has the vertical head attached onto here, onto the where the arbor goes, and then the knee is still attached to the machine with the lead screw for operating the knee. Now at the moment I've got this machine sitting on a pallet, and I have to move it around with a palletizer, which is not very convenient. And the palletizer and the pallet take up an awful lot of space. So what I've needed for some time now is a method of moving this machine around easily in the workshop to be able to gain access to all parts of it, and also to be able to get it outside so that I can paint strip it, because it's badly in need of a new paint job. Now this machine all up weighs about 800 kilograms, so it's not far off a ton. It's not as much as that at the moment because these heavy cast iron assemblies have been taken off, and also the electric motor, which is inside the base weldment here, has been removed as well. I took that off to change it from star to delta for a VFD conversion. So my plan is to manufacture some mild steel beams which will run lengthways along the base weldment here, underneath the chip tray, which is heavy duty, about probably about 5/8 of an inch thick steel, and they'll be bolted. The beams will be bolted with M12s to the side of this the weldment here, and then they'll have heavy duty jacks on them with heavy duty casters fitted onto the jacks to be able to jack the whole thing up to get it off the pallet initially, and then once it's off the pallet I can lower those jacks down somewhat and still wheel it around on the casters. So essentially make a pair of jacking casters out of a jack and a caster, and then attach that to a lifting beam, one on each side of the weldment. So without further ado, now I've explained all that to you, I shall get on and show you how I actually went about making those beams. I hope you enjoy it. So here is my solution to the lifting issue I've just been talking about with the milling machine. So what we have here is a 1200mm long piece of mild steel box, which is 120mm across and 60mm wide, or 120mm deep I should say, and 6mm wall. So it's heavy duty stuff, and it'll more than easily take the load of the milling machine. And what we've got here is a meaty jack these jacks are used for lifting or for clamping down static caravans, and this can take a load of 900 kilos. Inside here there's a 1/2 inch diameter trapezoidal screw or Acme screw and a lead nut to actually lift this up when you turn the handle, and it's got a hole pattern on the back, 3-inch hole pattern, or 3-inch between centers. I've actually you've just seen me drill another hole in this the bottom corner there, because it only had 3 to begin with. So basically the idea is to mount these jacks onto the beam, one at each end, and then have 2 beams. There's another piece of box underneath that one, a beam at each side of the milling machine held on with M12 bolts, and then we're going to get some heavy duty casters and bolt them to the bottom of the jack, so that when we rotate the handle we can jack the wheels down like an undercarriage, and that will lift up the milling machine. The beam will be bolted to the milling machine with, I think, probably about 4 M12s through the side of the base casting, and that's going to lift up the machine and allow us to wheel it around the workshop, and indeed wheel it around anywhere we need to. If we need to ever move it any great distance, we can put it in the back of a flatbed lorry or a flatbed van on a tail lift, and we can get it shifted. And the fact that I'm using such a heavy piece of box section and these jacks that can take 900 kilos, it might seem a little bit overkill, but the reason I'm doing this is because I've had issues moving this machine before, and in the worst case scenario, which is the one I always seem to get, I'll be moving things around single-handedly. So I want this to be well constructed and to be able to take not just the load of the machine, but uneven ground type point loading caused by that, or basically anything that circumstances can throw at it. So as per usual, I've over-engineered it, but I'm hoping that that's going to work in my favour. So there isn't a 4th hole in these jacks when they come new. So what I'm doing here is I've bolted the 2 back to back. I've already drilled a 4th hole in one of them, and I'm just going to use the one that I've drilled as a template to drill the second one. So we've got them drilled, we've got them bolted up back to back like this in the vise, and then we'll just drill through. So we've got the beam mounted on the table of the wrong foo clone. I've taken the vise off to get it on there, and we're now going to drill some 12.5mm clearance holes for the M12 bolts that will be holding the beam onto the milling machine. Well, I promised mediocrity, so never let it be said that I don't deliver. We're just drilling the M12 clearance holes in the beam now. So just put in a 6mm pilot drill through, and then we'll open them out to 12.5. Yeah, the temptation is always to grab that to slow it down, isn't it? Don't do it. Well, we've got one beam fully drilled up now with the clearance holes for the M12s and also the tapped holes for putting the jacks on. So let's get one of these assembled and see if it's looking the way I want it to, or as I envisage. Let's get this. Probably need to use an Allen key for that one. Right, I'll get an Allen key for these ones because they're in that channel, and I'll bring you back when I've got both jacks on, and we'll sit this thing up and have a look, see what it's like. Well, I still think he should have got a commission for these. He could have built his shed back up again by now, couldn't he? Well, thank you, Cliff, if you're watching this. You've raised the awareness that we all needed to install fire protection, and I hope everything's going well for you now. Who am I trying to kid? He's not going to be watching this. Now then, as a certain person used to say, can you tell what it is yet? That will mean nothing to you if you're not from the UK. We don't talk about him anymore. So you can see what's going on here. 4 M10s bolting each of these jacks to the beam itself. The wheels will be, or the casters rather, will be bolted to these plates. 2 M12 clearance holes at each end, which will go either through the milling machine body, or rather the base weldment of the milling machine, or the lathe weldment, depending on which machine you want to move. So that's how it should work, hopefully. All I need now is the casters. So these things jack up and down nicely. I can actually alter the length of these as well. I might have to modify them slightly, but we'll see. I may need to cut them down and reduce the length of the Acme threaded rod inside there, just to adjust the height of it. But we'll see anyway. It's all going well so far. So having literally just recorded a piece of footage of putting the beam together without the casters, the postman turned up and the casters have arrived from Bearing Boys. Here they are. So these are 250 kilo each, I think, capacity. So what we'll do now, you can see we've got one of the jacks in the vise. Let's get these on, and then we'll get the whole thing assembled, and we can see what one of the beams looks like, how it sits, and what the height is, and all the other key dimensions before we put it onto the milling machine. So let's get on with this, and I'll bring you back when it's on. So here we go. This is one of the lifting beams assembled, and you can see the general arrangement from this now. Ignore the clamp in the centre, that's just holding up the piece of wood to keep the whole beam assembly upright. So we've got the 2 jacks, one on each end, bolted on with the M10s. Then on the feet of the jacks we have the 250 kilogram capacity casters that arrived earlier on that I showed you. And then we have the 4 M12 clearance holes, 2 at each end, to bolt the beam either onto the weldment, base weldment of the milling machine or of the lathe, depending on which machine it is that we want to move. Now I might have to reduce the length of those jacks. I can do that fairly easily by cutting down the outer cylinder and the inner and reducing the length of the Acme threaded rod inside it. But we'll see how we get on with it anyway. So that's one of the lifting beams assembled. And we'll move on now and do the next one. Right then, so after a great deal of swearing and hitting it with hammers, I managed to get one of the beams on the side in position where I want it, held on with the clamp here, so I can spot through with the 12.5mm drill where I'm going to tap, or drill and tap the holes into the weldment, the base weldment. Oh, that means I'm going to have to take it off again, doesn't it? Anyway, let's have a look at some of the ideas I've utilised on this thing. So, as I said before, we've got the big mild steel beam. I originally drilled through 12.5 all the way through to have a bolt through there, but what I decided is the bearing strength of 1M12 inside there is going to be more than enough to take the weight of this thing. So I've opened these out to 20mm, which enables me to get a 10mm socketed Allen key through there to tighten up the cap head inside there, and also enables me to get the bolt in as well. So these are, as I said before, the 900 kilogram rated jacks that are normally used for levelling up static caravans, and they're held on with the M10s to each side. And then on the bottom, the 250 kilogram, you can see here, casters bolted to these jacking feet. Now everything that I've used on this, it's not based on the lifting capacity of what I've used, it's based on cost. So actually buying these jacks and then bolting the casters on them was cheaper than buying proper jacking casters. Likewise with the beam as well, it was pretty cheap. I was going to go for aluminium, and I wish I had done now, but the steel was a bit cheaper. Maybe Mark II will be aluminium after I've just sweated and sworn trying to get this on here. That's why I didn't film it, because this is aimed at, it's a family show, so we're not having any foul language on it. Anyway, so now I've shown you basically the idea of how this is going to go on. I'll get on and get this bolted up, get this drilled and tapped rather, and then we'll get the other one done. So you find me in the somewhat cramped, confined quarters between the bench and the milling machine. So here we go with side 2. So we've got the beam up, it's clamped on. Now I mentioned these were 1200mm long, these beams. The primary reason for that was to straddle this pallet that the milling machine's sitting on, but also the exact length of 1200mm was chosen so that these beams can also be used with the lathe. So they fit perfectly on that. And I'm hoping that once I've got these things on here and they're proven on the mill, it'll give me a system that I can use to easily move around any machine that I've got in here, or indeed any machine that I might get in the future. So I'm just going to spot these holes through now with the 12.5 just in the battery drill. Just spot them, and then we'll take this off. What a nightmare that's going to be. It's not too bad actually. And then we'll drill through and tap and get this on permanently, and now, well, semi-permanently, and then we can test the system and see that it works. So let's drill these through, or rather spot them through. That's one done. And I'll just spin you around so you can see the other ones. I think I'm going to have to move this makeshift tripod a little bit. There we go. Spot these ones. Oh, there we go. And the last one. Okay. Right, let's get this off and we'll get these drilled and tapped. So I drilled the holes, I opened them out to 10.2, which is the tapping drill size for M12. And I'm now putting the tap through. A bit of a tip, you can always, in a confined space, drive a tap. There's usually a bihexagonal socket that will fit it, because you've got a square in there across the bihex, and in this case it's a 5/16 AF for this particular tap. It's not as ideal as a tap wrench, but it works in confined spaces. So that's that through there. Let's take that out. So we'll put, that was the taper tap. We'll put the plug tap through now. Get a bit of row column there. Put that through, just to chase it out. Take it to the correct dimensions. So I'll get on, finish the two at the other side, and then we'll get the beam on and we'll be in a position to do a lift. Okay, we're just going to tighten this one up now, and then we're just going to go for this. We're going to do it in real time. Get these ones tightened up, one more to go in. So this could be embarrassing, or it could be good. We'll see. So we'll get this bolt in. And it's worth noting at this point that I didn't mention this before, but I intentionally wanted this beam to bear up against this top plate, the chip pan. It's heavy duty stuff, about 1/4 inch thick, and the whole of the body's bolted to that. So that's taking the weight. The weakest link obviously in this setup is the wheels. If I find that they start to complain or I start having problems with them, I can always replace them with higher spec ones, but I think they'll be okay. So that's that bolted on now. Worth noting as well that I've moved this jack forward a fraction, actually more than a fraction, by a set of holes. The purpose of that is not that I've made a mistake here, it's just that the flange for now on the jack is touching up against the pallet. Once I've got the machine off the pallet, I can then just move the jack back to where it's supposed to be. And it won't actually ever, I shouldn't need to be this high again. It's purely just to get it off this pallet now, is why I've jacked it up to this height. So let's give it a go. We'll take this thing up just enough to get it off the pallet. So we'll get the handles in position. So I'll try and jack it up evenly by eye on both sides. So if we start, this one's taking load now. That's not fouling on there. So let's get this one down some more. Okay. Right, it's definitely off the ground on this side. So let's, I'll move you over. This is going to be a bit amateurish, but then everything else I do is, so why not? Let's get this one up now on this side. Oh, I think it's okay. Yeah. Let's get this one up a bit more. I do believe it's working. Right, let's have a look. Okay, so the machine is now completely off the pallet. I'm completely free of the pallet. Let's take this one up a bit more. It's definitely working. There we are. Right, let's get this pallet out underneath here. Am I going to have enough room now? That is the question, isn't it? Let's try and take it. Okay, so that caster's just fouling slightly on the pallet. Hopefully you can still see all of this. Let's get this out. This is the main bugbear. Right, that's out. Let's get this out of the way. Right. So, now the moment of truth. I think we'll take this down a little bit actually. I don't think it's going to want to be this high. Take it down a bit. Right, that's that wheel off the ground, we don't want that. So we're going to have to move you over here again. Try and do this as evenly as I can. I suppose what I need really is a spirit level on the machine itself, but let's just do it. Take this wheel down a bit. Trying to get them to go evenly is the problem here at the moment. And you can definitely feel when one of them's got the load. Okay, so that's starting to tilt at a jaunty angle now. So So let's get the other side down a bit more. Move you somewhere where you can actually see what's going on, eh? That's not too bad there. Right. Let's get this side down. Yeah, you can definitely feel when the load transfers. Right, how are we looking for plum? Let's have a look. Oh, that's not too bad, just judging that by eye. Right, I want it down a bit more though. Let's take the front down. It's probably the best way to do it actually, isn't it? Is to do it front to back. Yeah, you can really feel it when the load comes on one and not the other. Okay, let's take the back down some more. Yeah. Can't see me now, but I'm winding the back down. Right. That one needs a bit of weight on it. Okay, right, let's try and move it now. Well, it's heavy. Oh yeah. Yep. It's empty. What's going on? Okay, so you've seen my solution to machine moving. It's fairly simple, it's fairly economical, it's modular, it can be taken apart easily to store it in here when I don't have much space, and it's also easy to swap it onto other machines and use it to move them around as well. And it's going to be a massive game changer for me in here because it means I can now easily move the milling machine around to work on it, get it outside, to get it paint stripped, and it also means that I can get rid of the pallet truck and the pallet, and that's going to give me a great deal more space in here. It's really going to free things up for me because I've really been struggling trying to work around this thing, so it's killed several birds with one stone. I really hope you enjoyed this this little video that I've made for you, and I hope you've gained some sort of inspiration or at least enjoyed watching me make this thing. Okay, see you on the next video.